Here's a drawing of water in a container at equilibrium. The water molecules are constantly changing from liquid to gas and the other way around at the same time. The molecules on the surface of the liquid will change to a gas once they gain enough energy to escape the intermolecular forces of the water. As the gas molecules move rapidly, some will touch the surface of the liquid. The intermolecular forces will cause the gas molecules to change into liquid. But suddenly, a non-volatile solute is added to the solution. I'm going to explain what a non-volatile solute is a bit later. Right now, the surface of a solution available for water molecules to escape into gas form is reduced. Therefore, the vapor pressure decreases because there's less molecules in the gas state. A non-volatile solute is a solute that does not have a vapor pressure of its own. If the solute does have a vapor pressure of its own, the vapor pressure of the solution may be greater than the vapor pressure of the solvent. Vapor pressure is a colligative property because it depends on the amount of solutes put in. Other colligative properties are boiling point, freezing point, and osmotic pressure. The definition of boiling point is the temperature at which the vapor pressure of the liquid equals the atmospheric pressure. Vapor pressure decreases, so more heat is needed to increase the vapor pressure to equal the atmospheric pressure. So the boiling point of the solution with a non-volatile solute is higher than the boiling point of the pure solvent. If I put even more solutes in, there's less space than before, and the vapor pressure decreases once again. Therefore, an even higher boiling point is needed. The more non-volatile solutes is added, the higher the boiling point. Freezing point is the temperature at which the solid and liquid are at equilibrium. Adding a non-volatile solute decreases the rate of freezing. But doesn't disrupt the rate of freezing. Adding a non-volatile solute decreases the rate of freezing, but doesn't disrupt the rate of melting. To re-establish equilibrium, a low temperature is needed. Thus, the freezing point of the solution is less than the freezing point of the pure solvent. With more solutes added, the rate of freezing is decreased even more, and a lower temperature is needed. The more solutes added, the lower the freezing point. This equation calculates the change in temperature. K is F and KB. Kf is the molar freezing point constant, which is 1.86 Celsius per molar T. And Kb is the molar boiling point constant, which is 0.51 Celsius over mole. I is the Van Hoff factor, the number of particles produced. The Van Hoff factor of covalent compounds is 1. For ionic compounds, I is the number of ions present. M, the molarity, is mole of solute over kg of solvent. To answer the 2 questions needed for this project, which are, does it matter how much solute I put in? How do changes in concentration affect the colligative properties? The more solute results in a higher molarity, which is the concentration unit, which results in higher change in temperature as seen by this equation and my explanation earlier.